The man who measured the speed of light in 1845 was an absolute genius. He was the French physicist Fischer. Let's see how he did it. This is the key component of the experiment, a special gear. Notice how every tooth and every gap in the gear is the same width. What's the point of this? I'll tell you later. Then we need a light source. It can be a light bulb or a candle, as long as it emits a beam of light. Next, we put a semi-reflective mirror in front of the light. This is a mirror that lets some of the light pass through and some of the light reflect back. We'll clean the semi-reflector a little bit. Finally, we put a normal mirror on the opposite side of the gear, and we're ready to start the experiment. When we turn on the light source, the light will first pass through the semi-reflector, then through the gap in the wheel to the opposite mirror. The mirror on the opposite side will reflect the light back and pass through the gap in the wheel again. And then it's reflected back into our eyes by the semi-reflector, so we can see the light. But what if we spin the wheel? You'll find that the light you see keeps flickering. Why is that? Because when the wheel is spinning, sometimes the teeth block the light, and sometimes there's a gap that lets the light through. What if we make the gears turn faster? You'll realize there's a moment when you can't see any light. And why is that? Well, it turns out that when the gears are spinning fast enough, the light is completely blocked by the teeth of the gears as it passes back and forth through the gears. That means that when the light comes from the right, it can get through the gap to the mirror on the left, but when it returns from the left, it hits the teeth. So we can't see any light at all. Pay attention. This phenomenon is actually the key that Fischer used to measure the speed of light. Once you know the speed of the gear and the distance between the gear and the mirror, you can use a simple formula to calculate the speed of light. According to the second grade formula, speed equals distance divided by time. Distance is the distance between the gear and the mirror multiplied by 2. Time is the amount of time it takes the gear to rotate one space. The gear Fischer used had 720 teeth and 720 slots. It makes 13 revolutions per second. So the time it takes the gear to turn a gap is 118,120 seconds. The distance from the gear to the mirror is 8 kilometers, so the round trip is 16,000 kilometers. Adding this to the formula gives us the speed of light as 299,520 kilometers per second. That's not far off from what we know about the speed of light today. It's hard to believe that Fischer could have measured the speed of light over 170 years ago with such a simple experiment. It's very impressive.